By the way, I forget to record all the time, so tell me to record when I start talking. But I started now. When you take a number and you raise it to a 0 power, it is always 1, right? A to the 0 power is 1. So if I have like 5 to the 0 power, that's a 0, it will be 1. If I have I to the 0 power, it will be 1. Do you remember what I is? Square root of -1, right? Yeah, so the reason behind that, if you want to just kind of think through this real fast, you could think of it as 2 to the first power over 2 to the first power, right? When we do powers like that, do you remember what you do with the exponents when you're dividing? We'll talk more about this today. Basically what happens is you subtract them, right? So 2 to the first power is 2. 2 to the first power is 2. 2 over 2 is 1, right? It's like saying 2 to the 1 minus 1 power. You take these two numbers and you subtract them. So 2 to the 0 power, just like 2 over 2 is 1, 2 to the 0 power then is 1. Okay, so that's why it works that way. That's the idea behind it. Second property that we're going to talk about says a to the m times a to the n will be a to the m plus n. So when we take those exponents and we're multiplying in between, notice the base is the same, right? These are both a base of a. When we multiply, we actually just add the exponents together. So it's like saying if I have 2 to the third power times 2 to the fourth power, that should be what? 2 to the seventh, right? It's like 2 times 2 times 2, right? That'd be 2 to the third power, times 2 to the fourth is 4 2s. Well, that's 1, 2, 3, 4, 5, 6, 7 2s. So it's 2 to the seventh power. Okay, so 2 to the third times 2 to the fourth is actually 2 to the seventh. Just add them together. It's basically 2 to the 3 plus 4. Division works very similarly. When we're dividing a to the m divided by a to the n, now we just take those powers, the m and the n, and because we're doing division, we subtract them now. So it becomes a to the m minus n. So it's like saying a to the third over a to the second should be a to the 3 minus 2, which would be a to the first power. Okay. So division, subtract, multiplication, you add. So far, so good? You're almost halfway through the properties. Okay. Number 4. This one's a little bit different. Notice you only have the one base here. So you're taking a power to a power, right? M to the nth power, a to the m to the nth. What happens is when you're taking those two powers, you actually just multiply those powers together. So it's like saying 2 to the third power to the second power. You're just going to do 2 to the 3 times 2 or 2 to the 6th power. Okay, so when it's a power to a power, just multiply those two numbers together. You can also do the reverse of that. So if I have AB to the mth power, you can just distribute that m, that power, to both things and separate them out if you need to. And you'll see as we go, when we do actual problems, how this becomes a little more clear why we would even do it that way, because it seems like we're making it more complex. But it is helpful in the end. You'll see as we go. Same thing here. Okay, this one, instead of saying a over b and taking that fraction to the mth power, that's such a weird way to say it, you can kind of distribute that m to both parts. So you can call it a to the m and b to the m and just put them over top of each other like this. Okay. Okay, the last one is probably the one that tends to give people the most trouble, I would say. Whenever there's a negative exponent, you have not simplified far enough, okay? So we want no negative exponents in our final answers. So what we do instead is a to the negative mth power. What it does is it moves that down. Sorry, I'm shedding. And makes it 1 over a to the positive mth power. So basically you drop this to the bottom, take away the negative, and put the 1 over top, and that will be your setup. So like 3 to the negative first power would be what? One over 3 to the first power, right? So it would just be 1 over 3, because technically we'd make it a positive 1, which is 1/3. Okay? Okay, now, this is a no-brainer, but it's also done wrong all the time. And I know you know it, but for some reason, when we throw exponents and negatives and all the things together, people's brains just kind of like revert to, I don't know what I'm doing with this for a little bit. So I'm just going to warn you right now. This, the number -3, does not equal 1/3, right? 3 to the negative first power. So if the power is up here with an exponent, that's when we flip it. But for some reason, because we are so used to flipping things as we go through this, people see a number like -3 and they go, oh, that's 1/3. -3 and 1/3, not the same number, right? So just be careful with that. If you see a negative out in front of a number, a whole number, a base number, don't try to flip things. Don't try to put it as a denominator and put a 1 over top, okay? Inevitably, it will happen at some point in time. I'm tempted to do it at times too. It's just this weird, I don't know. It just happens. Try to avoid it. So, okay, that's all we're learning today, is those 7 properties played out. So what we're going to do is we're going to talk through how we can solve these, how we can simplify each of these expressions. Like I said, make sure there are no negative exponents by the time you're done, right? We want to get rid of all the negative exponents, not the negative numbers. Negative numbers are okay. Negative exponents are not. So look at number 1 here. By the way, something else that I love, especially on quizzes and tests, but even on your homework, it's lovely, is if you'll box or highlight or circle or in some way signify what your final answer is. It's just so very helpful. It's helpful for you when you're checking your homework, that you can just look up and go, oh, my answer is this. What's the answer up there? It's fantastic. So box, highlight, whatever that means, please, please, please. All right, so number 1, what would you do first? You could do something with the negative. I probably wouldn't. You show you what I would do with that negative, because it's actually easy to make it positive. But you could. It's not wrong. It's just going to require more steps if you flip it, if you put it on the bottom. Anything else you maybe would do first? How about just 3 times 5, right? We're going to ditch the x's for a minute. We're going to multiply the numbers. So 3 times 5 is 15. And then it's x to the 9th times x to the negative 2nd, which is what?
7.
X to the 7th power, right? So this is where we're adding. 9 plus a negative 2 is 15 times x to the 7th. Is there anything else you can do to simplify that? That's it, right? That's your answer. So put a fancy box around it. Call it good. All right, number 2. What are you going to do with that? P to the negative 5th times p to the 2nd. What? You're going to add. Yep, p to the negative 5th. So it's basically saying p to the negative 5 plus 2 is what? P to the negative 3rd. Final answer? 1 over p to the third. You can't have that negative, right? So we're going to flip it, 1 over p to the third power. By the way, I didn't say this. I don't know, did Price have you turn your notes in at the end of the chapter? Okay, I do too. So make sure you take notes. This is your final answer then, 1 over p to the third. Okay. This one's a little bit tricky at times. See if you can figure out what that should be. Try that one on your own. Negatives can sometimes cause a little drama. Pay attention to those negatives. What'd you get?
1 over 3r squared.
1 over 3r squared. Anyone else get that? It's not quite right. Anyone get something different? What'd you get, Kate?
I got 1 over 3r 14 squared.
To the 14th power? To the 14th power.
Yeah.
Okay. That's not right either, but I appreciate the effort. Anyone have a 3 in the numerator? Let's think about this. 12 divided by 4 is the number 3, right? Not 1/3. So the 3 should be on top. 12 divided by 4 is 3. And now if you take this, r to the negative 8th and r to the negative 6th, what are we doing with those two numbers? Subtracting them. So it's basically saying r to the negative 8th minus a negative 6th, right? So plus a positive here makes this r to what power? Negative 2. Okay, so right now, if you forget about this, we have 3 times r to the negative 2nd power. What do you do with that? We move just the r, right? The 3 is going to stay. The 3 is a positive whole number on top. It's our numerator. R squared has to get moved down. So 3 over r squared. It's a little tricky, right? That one's a little funky. Okay, number 4. What do you get there?
1 over x to the 7th.
Yeah, so this should be x to the negative 7th if we add them together, right? Negative 2 plus negative 5 is going to give you a negative 7, and that becomes 1 over x to the 7th. And that's as far as you can go with it. Okay, number 5. Similar to that one that we said was tricky before, kind of similar to number 3, right? What do you get? What's your number? Forget the variable for now. Negative 5. Nothing happens to that, right? That's just going to be up on top, negative 5. What does this become? Not negative 8, because we're doing negative 3 minus a negative 5, right? So it's r to the negative 3rd minus a negative 5, which is r squared, okay? That number is on top. That's your numerator right now. When you subtract those, it's whatever you get is in your numerator. So r squared goes here. Here's where people are tempted. See that negative 5? People see that and they think, oh, it's a negative. I got to move it down. You don't. It's just the number negative 5. So don't try to drop that one to the denominator. Negative 5 times r squared. Any questions on that? All right. Number 6. P to the 0 over p to the negative 3rd. What do you get? We have a couple options here. What's p to the 0 power? 1. So you could think of that right now as 1 over p to the negative third. I don't typically think of it like that. I usually think of this as p to the 0 minus a negative 3, right? Subtract your exponents. So you get p to the third power. Either way, that's where you would end up. It's just a matter of, do you want to subtract them, or do you want to think of that p to the 0 as 1? That's fine too. All right, number 7. What would you do here? You would what? How would you multiply the top? Okay, we don't want to do that. We want to deal with the exponents for them. So they all have the same base, which is lovely. You have a 2 and a 2 and a 2. But we don't want to call that 4 to some power. You have to keep the base the same. So when we have, remember this was like a to the n times a to the m. We made that a to the n times m, right? So we're going to, n plus m. I said it wrong. So we're going to add our exponents. That's going to be 2 to the 8 plus negative 6, which is 2 to the, what power? To the second power, yeah, over 2 to the second power. So this is 2 to the second over 2 to the second. What is that?
1.
It's 1. Isn't that lovely? You could subtract those, right? 2 minus 2, that would be 2 to the 0 power, which is 1. Or you can just think of that as 4 over 4 is 1. That's fine too. Lots of ways to get there, which is kind of nice. Okay, number 8. What do you do with that? 2q, and we're taking that whole thing to the 4th power. What do you do? You're going to distribute it. Yeah, 2 to the 4th and q to the 4th. Okay, so 2 to the 4th times q to the 4th. Anyone know what 2 to the 4th power is off the top of your head?
16.
It's 16. Good job. P.S. I was playing cards with my family over the break. My mental math, after 2 weeks of not doing mental math, gets horrible. So I can only imagine how you feel about your mental math after 2 weeks of not doing it. You'll get back to it. It'll come back. I literally was like trying to do just basic addition and subtraction, and it was like, carry the 3, what's the, it's not good. But it'll come back. Okay, 9. What do we do here? Same basic idea, right? Distribute that 3. What's negative 3 to the 3rd power? A negative 27. Yep. Negative 3 times negative 3 times negative 3. By the way, your calculator will do that for you, but if you plug it in negative 3 to the 3rd power, now with a 3rd power, it doesn't matter. But when it's like an even numbered power, if you don't put those parentheses around it, it's going to tell you the wrong answer because your calculator thinks you're saying, like if I go negative 4 to the 4th power, if I plug that in, my calculator thinks I'm saying the opposite of 4 to the 4th power. If you want it to do the right math for you, you need to say negative 4 to the 4th power, so it keeps that negative 4 as the thing we're taking to the 4th power, okay? Anyway, back to this. So negative 27 for negative 3 to the 3rd power. Y to the 3rd power is just going to be y to the 3rd power, so it looks like that. Questions on that? Okay. I want you to try the next 3 on your own right now. So 10, 11, and 12. Give that a go on your own. All right. What'd you get on number 10? Negative 125, and then s to the 3rd behind it? Not quite. Below it, right? Over, so we're going to distribute that 3 to both these things, s to the 3rd, and that will be your answer. Okay, number 11. You're taking a negative 3m.
For number 10,
I totally get where you're coming from with that. The only issue is your bases are different. So you're the 125 and the S. We don't know that S is a negative 125. You can only do that. You can only subtract them when your base is the same number. So we can't subtract those right now because they don't both have the negative 125 or they don't both have the S. Does that make sense?
Yeah.
Good question. Okay, so number 11 here. If we're taking both those things to the negative second power, what's our first step then? Okay, so you could distribute it. How many of you distributed the negative 2? Yeah, totally fine. You can totally do that. I don't do that because my brain just does it a different way. What I do when I take something to a negative second power like that, I typically just flip the whole thing right away because I like to get positives right away. So I do it like this. I do 1 over, and now it's negative 3m to the positive second power, right? When you flip it like that, it becomes the positive power on bottom. But if you distributed, that's totally fine. Let me show you the distributing way. So if you do negative 3 to the negative second times m to the negative second, that's fine. Now you just have to flip them both. So that's up to you. I'm going to run with it this way just because I do think it's a little bit simpler, less messy maybe. So if I square this, I get 1 over negative 3 to the second power is 9. Remember, keep that parenthesis with it if you're going to plug it into your calculator. And then m to the second power is what we're left with here. So it should look like that by the time you're done with it. But like I said, if you want to do it this way and then flip from there, that's fine too. Okay, number 12. What did you get?
D
32d to the 15th. Yeah, so if you, where'd we go? If you distribute that fifth power, it's 2 to the 5th power and then d to the 15th power, right? That's when we multiply. When we don't have that second d base, we just multiply those numbers instead. And 2 to the 5th power is 32. So 32d to the 15th. Okay? Questions on any of those? Did you get any of those on your own, hopefully? Yeah? Okay. Last 3, and then we're done. Okay, so here's the deal with this one. Again, there's a couple ways that you can do this. The way that I would do it, I don't typically distribute the negative 5 to both things right off the bat. What I do is basically if you have a negative power, whatever was on bottom is going to go on top, and whatever is on top is going to go on bottom. So what I would do is I would flip it to over y to the 4th and take that whole thing to the positive 5th power now. Okay, because that negative 5 is going to bring the bottom to the top, the numerator to the denominator to the numerator. So I would do it like this and now distribute that 5. So it's going to be 2 to the 5th power, which we just said was 32. And then y to the 4th to the 5th is what? Do you add them or multiply them? You multiply those. Yep. If there's not a second y base, a power to a power gets multiplied. So it's y to the 20th. Okay. Questions on that? All right. Almost there. This one has a lot going on. Yes, ma'am.
I was wondering if you could show me the answer. Wait, how did you get the, you flipped it?
So we flipped it because of this negative, right? If I take this to the negative, I mean, you don't have to. You could just distribute this right off the bat. This would be y to the negative 20th over 2 to the negative 5th, right? But those negative exponents move all of that to the opposite place. So if it's in a denominator, it's going to get moved up to take the negative away. So 2 to the 5th would be your numerator, and then move it down to take this negative away. Y to the 20th would be your denominator. Yeah, so the negative exponent always moves you to the opposite place that you're at.
Is that a 32?
Yeah, 2 to the 5th is 32. Okay, this one. I would probably, what would I do? I would probably just distribute that 4 right off the bat. Yeah, let's do that. So we're gonna take this 4th power to every piece of it. So 2 to the 2nd to the 4th is actually 2 to the what? The 8th, yeah, you're gonna multiply those. So 2 to the 8th, and then x to the 16th, we're gonna multiply 4 times 4, so x to the 16th. Y to the what? -8. And then z over z to the what? The 12th. You got to distribute the 4 to the bottom also, so z to the 12th. Okay, so here we are. Now we can simplify. 2 to the 8th power, plug it into your calculator. I don't expect you to know that off the top of your head. 2 to the 8th power is 256. X to the 16th can stay put because it's positive. What has to happen with that y to the -8? What do you do with a negative exponent? Flip it, right? So what's on top there is going to get moved to the bottom. So it's going to be y to a positive 8th power on bottom. And then we have z to the 12th. And that's as much as you can do with that. So that will be your final answer. Questions on that? All right, last one. So for this one, we are going to distribute that -2, at least that's what I would do right off the bat. So to all 3 of these things, I went too far. So I would do -3 to the -2nd power, and then it's a to the what? Which power? +4. See how nice that is? When it's a negative and a negative, it actually becomes the positive. That's why I say distribute it before you start flipping things. And then b to the 6th power. Yeah. So the only thing that needs to move is that -3 to the -2nd. That means we're going to end up with an a to the 4th and a b to the 6th on top. What do we have on bottom? -3 to the positive 2nd power, which is 9. So it's just a to the 4th, b to the 6th, and then 9 on bottom, and that is your answer. And you made it with a couple minutes to